to keep the same value for each bond in a polyatomic ion, because once you break the first ICl bond in this molecule, then it will actually change the energy of what's left over, because it's a different molecule. In fact, I'm going to go on with this because it's super important. If you have a C bonded to an O bonded to an H, that would be very different than the energy of an N bonded to an O to an H, because as soon as you break this, it's just different. We're going to learn, you guys will learn in organic chemistry that there's stability. This N and O would stabilize a negative charge. If there were a negative charge on here, way more than a C and an O. So this problem that we're doing is not exactly accurate, but it's what we got. I'm still going to consider for this problem, this is the only information I got, that we have 3 of these bonds, an I and a Cl and an I and a Cl and I and a Cl, and we have 2 of them, so I'm going to take 6, and we're now doing the products. Just know it's not as straightforward as that. You can measure bond energies for diatomic molecules directly, but you can't. It's not, just gets more complicated with polyatomic ions. I don't know if they'll have a free response question about that on your test at the end of the year, but kind of makes sense. So 6 times 2, 10. Once again, if you want me to draw the molecule, we have an I bonded to 3 Cls. Okay, and we're talking about we need the energy here. There's 1, 2, 3, and then we have 2 a whole thing. So that's why I'm getting the 6. If you're ever wondering, 6 times 2, 10. This is equal to 1260. Oops, and this one was. So we have the binding energy for the reactants minus the products. Eight 70 minus 1260, get negative 390. Sweet. Okay, last question on this page. For the combustion of butane, this is how much enthalpy, how much heat is given off in kilojoules per mole for this reaction. Good. Assuming complete combustion, which process generates the least amount of heat? So it says burning 1 mole of butane with excess O2, burning 1 mole of O2 with excess butane. So what I'm looking at here is I'm thinking that doesn't make any sense. If we look at our stoichiometric coefficients, burning 1 mole of butane will basically give you half of that amount if we had plenty of that. Agreed? So here I'm just going to say half of delta H. Keep some tracks and notes. Burning 1 mole will give me half of delta H. Good. Burning 1 mole of O2 with excess butane, this would limit our reaction by a 13th, right? Or something much smaller. Is that right? Yeah. Producing 1 mole of CO2 by burning butane. If we only produce 1 mole of this, then that means only 1/8 of delta H could have happened. Producing 1 mole of water, and this would be 1/10 of delta H. So which process generates the least amount of heat? for sure by limiting our water because it requires them, I mean our oxygen because it requires them most. So I'm going to choose B, and I hope you guys are okay with that because that one makes sense. Okay, I'm going to post this one and go on to page 2.